Hey everybody. Today we're getting started with lists in R. Lists are a very flexible data structure that generalize the idea of a vector, with the important difference that lists can include many different data structures all at once, whereas a vector is restricted to just a single data type. Let's jump in and make one. So I've already coded in a few different atomic vectors, nums, words, and logicals, as well as loading up tidyverse. And I'm going to make my first list. I'm going to call it L1 using the list command, naturally enough. And it's just going to consist of nums, words, and logicals. And I'm doing this mostly just so that we can see what a list will actually look like. So let's print it out. All right. So we can see here that we have 3 items in our list. The first, which is being denoted bracket bracket 1, is this vector of length 5, nums. And the second, bracket bracket 2, is hello world. And the third is this logical vector, logicals, true false. We can see the structure of this vector a little bit more explicitly with str, structure. So let's do that. And this will explicitly tell us that we have a list of length 3, and the first element of that list is an integer vector of length 5, the second is a character vector of length 1, and so on. We can extract elements from a list in a very similar way as with vectors. So L1 bracket 1 is going to take the first element of the list, bracket bracket 1. Now notice right away that this L1 bracket 1 is another list. We can see that explicitly with str parenthesis L1 bracket 1, a list of length 1. Just as subsetting a vector tends to give you back another vector, subsetting a list tends to give you back another list. And that's great, that's logical in its way, but frequently you'll actually want to get your hands on this underlying vector. And R provides a natural way to do that. This notation here is very suggestive. The first element of the list is called bracket bracket 1, and so we can extract the first element of the list using that. L1 bracket bracket 1 is then just going to be that vector. So the single bracket notation gave us back a list. It left the structure intact. The double brackets stripped away a layer of structure and just gave us the actual object that was lying inside of that first element of the list. If I put in the structure of L1 bracket bracket 1, we'd see that we had an integer vector. We can create lists where the elements have names. So let's do that. Let's call our next list L2. And I want A, the first element of my list, to be the numbers from 1 to 10. B can just be hi. And C, let's just have it be all the letters of the alphabet, which R has hard-coded. And let's see that now. All right. So very similar output as before. Notice that we don't have bracket bracket 1, 2, and 3 anymore. Instead, we have $A, B, and C. So the names are written here explicitly. And we can extract things from this list now using that $sign notation. For instance, L2 $A. This kind of notation will be very familiar to almost all of you, because if you've ever worked with the data frames, I'm sure all of you have, you'll know this is how you extract columns from your data frame. And in fact, data frames are just an extension of the idea of a list. They're a specific sort of list. Notice, however, that L2 $A is a vector, not a list. So in that sense, when I do L2 $A, it's more like subsetting with these double brackets. As I said before, lists can get pretty complicated. They are wonderfully flexible data structures that can be used to store a tremendous diversity of sorts of data. Let's just see a little example of that. Let's make a list called L3. And inside of L3, I'm going to start, how about just with letters? The second element of my list is going to be another list, L1. And then the third element of my list is going to be a data frame, msleep, which was loaded up when I loaded tidyverse. This is in, I believe, the ggplot2 package. All right, let's see what we got. Let's see the structure of L3. Okay, so as we expected, it is a list of length 3. First, we just have a character vector. Second, we have a list of length 3. And then finally, we have this tibble, this data frame for msleep. Lists can get pretty complicated. You will see lists within lists within lists. Nested lists are extremely common. You will also see lists that include many different data frames. And in my working life, that's where I deal with lists the most. Just I will have a list with a tremendous number of different data frames that may have all come from the same source, maybe even have all been split off from that same data frame. Let's do a quick example of that last before we wrap up this vid. I'm going to use this mSleep dataset that I mentioned before. Here we have 83 different mammals broken down by their vor. In other words, what they eat. Are they carnivores, omnivores, etc.? And I believe there are 6 different vors in here. So let's make a list. Let's call it mammals list. And I'm going to take the mSleep dataset and I'm going to pipe that into a group by. I'll throw a link to group by and summarize at the top of the vid here. Let's group it by vor. And then I am going to do a group split of that. I don't think I need any other arguments there. What this is going to do is it's going to take my data set here and it's going to split it into one data set each for every value of vor. So it's going to split it into a data frame by that vor variable. Okay, so let's see this structure of the mammals list. Okay, so there's extra information here because of the group split command that I won't talk about. The fundamental thing to recognize is that we have a list with 5 things in it. Let's look at one or two of these. Mammals list, bracket, bracket 1, using that new notation. Let's get the first element of that list. We know that's going to be a data frame. And let's view it. Actually, I could just print this because it's a tibble. It should print nicely. Let's not mess around with the viewer. Okay, so you see here that we have a tibble with 19 rows and 11 columns. These are all the carnivores. If I like, I can do mammals list 2 to see all the herbivores, and mammals list 3 to see all the insectivores, and so on. So that's just one application of lists in R.